This is the supplemental lecture video number 5 for JIT 70. All right, today we're going to have some interesting topics, right? We'll have 5.1 compound interest, 5.2 exponential equations, and 5.3 log equations. And then the first one is one of my favorites because that applies and the topic connects to the real world. Right. So the example number 1 shows you how the compound interest work. And then this is the type of question I designed to show you how each rate of interest makes you earn different amount of money at the end. So let's pay attention to this one. All right, so first of all, the equation you should have learned in the lecture video is A equals to P times 1 plus R over N to the N times T. Right, so if you watch Tyler's video and you can see that he explains this equation, he explains every single symbols and shows you how they work. And most importantly, we have to know that N stands for the number of compound per year. All right, and then the one thing I can add is that we have a 1 plus the fraction for calculating the total amount. And then that, if you don't have the value of 1 included in the equation, then the only thing you'll be calculating is the interest you earn instead of the total amount you have in your bank account, right? And then the mathematician crafted this equation for us to calculate how much money we own at the end of 5 years, for example, in this example. Right. And then for accountants in the real workplace and for the bankers also, they know this equation, they understand and know how to use this equation to calculate the amount for their customers. So they know the mechanism inside out from the book, and then that's what you expect to do if you become a professional banker, right? And they can do this job without checking their notes, right? So that's one of the reasons notes are not allowed during a test in a certain class. Just some of the classes, but not all of the classes, by the way. Okay, so let's figure out the different versions of the compound and then see what we have. So first of all, in this question, we know that P stands for the percent value, which is $46,100. And then that'll be the same for all 5 parts. And then T stands for 5 because we have the number of years assigned as 5. And then we have the rate, which is 6% per year. So if you divide the 6 by 100, then you'll get 0.06. So that's how you convert a percentage into a number. And then how about N, right? So the value of N depends on the situation. And this is the part I want to show you here. In part A, the number of compound per year is 1 for the annual version. So what does it mean? That means your interest is calculated and added once per year. So your equation is going to be set as 46,100 times 1, and we're plugging our R, and then we're plugging the N in this question, and then we plug in the power as 1 times 5. right? So that means your interest is computed 5 times within the 5 years given, and that helps you figure out the final amount you have in your bank account. So remember, this is not 1.5, this is 1 times 5. Maybe I should put down the multiplication sign. All right. So we'll calculate the final amount later. Let me show you the mechanism because that's more important. All right, so what if you have a semi-annual rate for your bank account? No, for every single bank, so things are different. Sometimes they allow you to do the same semi-annual rate, and then now your n equals to 2. So the n equals to 2 is telling you that your interest is calculated and added twice per year in your account. Okay, so same setting, but we changed the n to 2, and then do the same thing on the power. So your reduced fraction, and then the finalized equation will be 1 plus 0.03. So now you can see that number telling you that, hey, for every 6 months, the rate is 0.03. So when you get to year, when you turn it into the time into year, then you'll double the rate, which gives you 0.06. Well, this is how the semi-annual compound works. And then you have a power of 10 telling you that your interest is calculated for 10 times within the 5 years, twice per year. So in 5 years, you'll have 2 times 5 equals to 10, right? Okay, and we'll leave the final answer there, and then I'll show you the next one. How about you have a monthly rate? You have 12 months per year, right? So your interest will be calculated for 12 times per year. And then in 5 years, then that'll be 12, that'll be 5 times 12. So this is how your equation looks like. Again, just replace the n by 12 for this scenario. And then you'll have the percent value times 1 plus 0.06 divided by 12. That will be 0.005. You can verify that in your calculator, and the power is 60. All right. Right, this is another common rate in the real bank. Okay, next, daily rate. Right, this is the less common one. Right, so if we disregard the lunar year, then we can assume that n equals to 365 because we have 365 days per year. So that means your interest is calculated 365 times per year. So that will make your fraction be 0.06 over 365. And then I don't want to calculate that by in my mind, so I'll just leave the next step blank. Well, anyway, you know how the setting is like. All right. Most interestingly, what if you have a continuous compound? What does it mean? So that means your interest, when you input your interest, then your amount of money will keep growing over time, which is very cool. But this is also the less common compound method you can find in your certain account. Let me show you. All right, so for part E, this is probably not covered in the regular video, but to find the continuous, to find how your amount works with the continuous compound, you need a special equation, which is A equals to P times E to the R times T. And then E is called the exponential function. And then it's more clear if we explain this on the graph. So let's say that your amount A depends on the time. And then let's say that P is your initial amount right there, for example. So that number on the y-axis will be, for example, $46,100. And then the exponential function would be something like that to show how your money grows continuously over time. So that means when you put your money into the bank and then if the bank allows you to use a continuous rate, then your money will automatically grows over time. And then you wait for 5 years, and then they'll tell you how much you have at the end. So this is called the exponential function, which is how the P e to the power works then, right? It's very cool. And then if we plug in the values, then we have 46,100 times E to the R, which is 0.06, and then time would be 5. So these are the numbers you plug in. And then that exponential function is made up by mathematician for the certain application. And it really works in some situation. Okay, now we're going to calculate the final amount and compare them. That is the purpose of this question. So in part A, if you have your scientific calculator, then you should be able to calculate each of them. So the first amount will be 61,692.2. If you want 2 decimal points, then we can leave it there. So for the annual rate, that's how much money you own 5 years later for your account. Next, in part B, plug in all the numbers, then your final amount will be $61954.55. Right. And you can see that your money is a little bit more than that from the annual rate. Okay, in part C, plug in 0.005 and this power of 60. So you repeat using your calculator, then you will see your amount as 62,181.99. Okay, the number is a little bit greater. Yes. Okay, next, part D, plug in all the numbers into your calculators, and then let's see what we have this time. Well, look, we have 62,226.96. Number is even greater. Yes. Okay. Now, the last but not least. You apply the exponential function, and remember, you can only do this with a scientific calculator, right? This is the extra part from this supplemental video, but it's also interesting to figure out what we have. You have 62,228.49. All right. Okay, so the money you have is the greatest in part E. That is why the daily rate and the continuous rates are the least common for your bank or your student loan account. Because if you have greedy bankers, for example, then they'll realize that customers will earn more money if they go for these rates. So they will try their best to make you use make you have your annual rates or sometimes a semi-annual rate for your bank account, and then they'll try their best to avoid letting you apply the daily rate and the continuous rate, because that will make you earn more money, right? So if you happen to meet a bank which offered continuous compound, be thankful, right? All right, so hopefully you learned something interesting in example number 1. All right, next, example number 2. Right, this is a single example, and then, right, you're trained to know that when you see any scenario given, then you should know how to find the certain final amount. Oh, forgot to put down P there. All right, so you deposit 5,000, and then you have a monthly, you have a 5% interest compounded monthly, right? And again, the meaning of compound is covered in the regular lecture video. How much will you have in the account in 5 years? Right, this is merely another similar examples. But if you are starting, then I will suggest that you list the variables given first, so that you understand what to do later. So that deposit amount, that is your percent value. And then the R will be 5%, which turns into 0.05. And then if you have monthly rate, if you have a monthly rate, then the number of compound per year is 12. And make sure you understand that key information, right? To be a professional banker or accountant, you have to understand how the and works. It's extremely important. And then T equals to 5, right? Now it's time to plug in the numbers. Your interest is calculated 12 times per year. So that's why we have the rate divided by the 12, and then we have the number of period as 12 times 5, which means your interest is computed 60 times within 5 years. Okay, so right, and then if you use the similar equation in setting in your calculator, then your answer will be 6,416.79. So that's the amount of money you have 5 years later. So that means you earn about $1,416 more after 5 years. If we assume that our interest is not paid as tax, yes. Right, so as you can see, the model we earn is the simplest one to estimate how much interest, how much final amount you have based on the interest and the rate method you have. Right, and things are not that simple in the real world because the interest can change over time, which is annoying, right? But we have the model, but we normally work on the question with the simplest assumption. All right, example 3. Fatuma invest $9,000 at 5% simple interest for 2 years. How much interest did Fatuma earn over the 2 years? And then how much is in the account at the end of the 2 years? All right, so this is the part to show you how the interest is calculated alone. Let me show you. All right, so this is how the simple interest works. right? Let me show you. This is probably not covered, so I can show you in this video. So the simple interest equation will be P, defined as P times R times T. So that means when you have the interest applied to your certain investment, then they will just calculate your interest once. And no matter how many years you have, they just have you calculate that amount once and then say, hey, this is how much you will earn 2 years later. Right. So this equation will help us answer the first question. Right. So the simple interest, let's call this part A, and then that is part B. So that equation which shows that you have 9,000 times 0.05 because R equals to 0.05, and then I should have listed right here, and then T is 2 years. So this, again, when you plug in a number, then you'll see that, hey, if you have 9,000 times 0.05, then that would be your interest for a year. And then if you just double that number, then you'll get the interest for 2 years. So the answer will be $900. So if they don't calculate your interest every year and add it to your account, but instead they just do it once, just once, then that's how it works. That's the that's the amount you earn. And then the account at the end of the year will be calculated this way. And there's no standard equation for this time. Right. So the final amount will just be 9,000 plus 900. You're just adding the interest earned separately with your initial value, then that's the total amount of money you have at the end. All right. So that means you earn $900 extra, and then you have the total amount of 9,900 2 years later. All right. And it is interesting to see how that works for the example number 1. So let's take a look, shall we? Right. So we can calculate that amount and then compare. So this is an extra section to see how much we've earned. If we apply the simple interest method, so PRT for the first example, it gives you 46,100 times the interest, which is 0.06, times the year number, which is 5, number of years. So what do you have? You have 13,830. Yes. And then in this method, your A, what would your A be? The A will be the percent value plus the interest earned. Then you have, guess what? You have even more money than, oh wait, no, that's not right. You have least amount of money. Right. And then that's even less than $60,000. Right. And then that is another less common interest rate, because customer will not earn much. Right. And then I've never seen a bank which applies a simple interest to your money, because customers prefer growing their money over time, right? Instead of having it calculated once. All right. So now you learn that the continuous compound does make you earn the most. And I take my word back. The continuous compound method is indeed covered in the lecture video, in the regular lecture video. All right. Okay, now let's go over the next section. Right, so let's check out the property of exponents and then solve the equation like that. And then this will allow you to see how to apply a certain method to solve for the unknown, such as n, right? So this is no longer a compound interest problem, and this is a totally different problem to work on. All right, so you have 1/10 to the n equals to 1,000. So we have to understand what a like-base property is. So that means you are going to set the base value for, you got to make sure you turn the base value into the same thing for both sides of the equation. And then I'll give you a quick example. So if you have 10 to the 2, so the value right there is called the base, and then the value right there is called power, but it's also called the exponent. So the n is your exponent in this example, and that's what you're finding. All right, so there are different ways to approach the answer, and then I'll show you what to do. Right, so if you recall the scientific notation, you should know that 1,000 equals to 10 to the 3, to indicate that you have 3 zeros for that number. And then, right, now you're making up an exponent, which is not quite matched to the others because the base on both sides are still different. But if you recall that, right, so let me put this down. So if you recall the scientific notation, you can get that information. And then you can also realize that 1/10 equals to what? That equals to 0.1, which is also 10 to the -1, right? All right. So if that works, then that means 1/10 to the n equals to 10 to the 1 times n, because you're turning that portion, you're turning the base into 10 to the -1, and then just multiply the power of -1 by n, and then that's how you turn this fraction into 10 to the -n. And why are we doing this? Because we are doing this to make sure the base values are matched on both sides of the equation, right? And we're getting somewhere now because the bases are now 10. So my advice is that it's the easiest if you turn your base into a simple value such as 10, which is common. And then you can equate both exponents. Then you have -n equals to 3. So to solve for the answer, you flip the sign and you get n equals to -3. Right. And then if you check with the original equation, then you can see how the information match. 1/10 to the -3 is indeed 1,000. You can check that with your calculator, and then, right, it'll give you the same. It should give you the same answer. Right. So this is how the like base property works. The goal is always the same. You turn the base values into the same for both sides of the equation. Well, let's practice another one. Example number 5. Solve this equation. So that means we are solving for x. That's what we're doing. All right. So you have a base on the left as 64, and you have the base on the right as 4. So what you should do is to turn two bases into the same thing together. So 64 is the greater number. So we can think about what that looks like if you have the base value as 4. And it actually works, because if you have 64, then that would be 4 times 4 times 4. And then, right, if you multiply the 4 by 3 times, then you should, I know, if you multiply the number twice, then you have 4 times 4 times 4, and then that's exactly 64. And then that is equivalent to 4 to the 3. Okay, so 64 turns into 4 to the 3. So what does it tell you? You have a power as 3 showing up on the left-hand side of the equation. So that power can be multiplied by the unknown part, which is 2x minus 3. So the method will always work. That's how you combine two separated exponents. You multiply them. That is the rule we follow. And then if you recall what 4 is like when you apply the power, then that would be 4 to the 1, because that means there's only one value of 4 in that formula, and then there's no way for you to make up something else. So that's the like base property setting again. And we have achieved the goal by making up the same bases on both sides of the equation. And then that means we can equate the exponents from both sides as well. So that is the equation for you to work on for the final answer. All right, and then the rest of the work will be just the algebra work. So we'll do it quick, because we have learned how to handle this algebra already. So 3's are divided out, which gives you 2x minus 3 over equals to 1 over 3. And then next, we will add both sides of the equation by 3. Then you will have these two numbers cancel, then you get 2x equals to 1 over 3 plus 3. And then if you combine the fraction with a number, then you'll get 2x equals to 1 over 3 plus 9 over 3. You turn the value of 3 into fraction, and then you'll get 10 over 3. And then you divide the equation by 2, then the answer will be 10 over 6. And then reduce the fraction again, then you'll get 5 over 3. So the final answer will be 5 over 3 for example 5. Okay. All right, next. Right, so that's how you solve for the unknown if you have a setting like this. All right, next, let's check out how we work on the logarithm function. So example number 6, write as an exponent. Do not evaluate it, just convert it to exponent form. So if you see this type of question, then that means you don't need to calculate anything. You just have to turn the log equation into the exponent equation. That's what a regular lecture video shows you. All right, so we have seen the regular formula as log b with the base a, which gives you x. And then that matches the exponent equation, which will be a to the x equals to b. So mathematicians created the log equations for us to solve for the power directly. That is the purpose of a log equation. And then your goal is, in example 6, is not to calculate, right? You have to understand the language when you read the question, right? And instead, turn that either this function to that function or do it the other way around. So let me show you, right? The base will be 8, and then the result will be 5, and the power will be t. So in this question, you're turning the logarithm function into the exponent form, right? So that's how it works, right? And then we have the same info here. 4 is the base value, and then the exponent is 9, so that gives you the final result as m. And we don't need to calculate m, we just need to convert the form into others. And then the third question, we have the exponent form of the equation, and the goal is to convert that to the logarithm form, right? Do you forget to add another statement, or do it other way around? Right. So when you see an exponent form, then you need that in the log form. So the answer will be log. But what is the base value? Think about it. That would be 8, right? And then what is the exponent? What is the power? That would be m. So m is going there, and then the result is 7. So you have log of 7 equals to m. So the conversion method works when you're actually calculating something. For example, you're evaluating the log of 4 to the 1/16, and then, right, this is where we can apply the conversion method. And let me show you, right? So first of all, there's no way to find the answer directly unless you use your calculator. And then assume that we don't use calculator on this question, which will be the case for the exam, for the test. So, right, we can first of all let that be x. Want to follow the format. Is that x in the default equation? Yes, it is. Right, so we'll let that be x, and then if I convert that log function into the exponent function, then that would be 4 to the x equals to 1/16, right? Now we're getting somewhere. This like-based property can be applied. 1/16 equals to 4 to the -2. Let me go over that step by step. 1/16, well, gives you something like 1/4 squared, and then, right, we are finding the like base again. So 1/4 turns into 4 to the -1, and that's multiplied by the extra power of 2. And then what do you get? You have 4 to the x equals to 4 to the -2. Now the like base is found, so we learn that x equals to -2. So we found the x, right? That's the answer. That's -2. That's exactly what you're doing in this problem. But if you practice enough and you can tell the answers when you reach that step, then you don't need to show the detailed procedures. And so it's totally okay to show x as -2. All right. Now we have another challenge in question. Right, so we have the log base 2 with result 5x plus 3 equals to 2. All right. So, sometimes the value of x can be confusing, but because the x here is not exactly the power of the exponent, you have to sometimes deal with the symboling method sometimes. But anyway, what we are having is that we have the base of 2 apply with the power of 2 that gives you the result, which is 5x plus 3. So let me show you that power shows up right there. And then the result as 5x plus 3 will be indicated on the right-hand side of the equation on the exponent function. All right, and then that is the equation for you to solve for the x, right? The unknown. Okay, 2 to the 2, and this you don't need the base method because we have 2 to the 2, which is exactly 4, and then that will make that will turn the problem solving simple, and then you have 4 equals to 5x plus 3, and then the rest will just be the algebra work. These two values are canceled, so you have 1 over 5x, and then you divide the equation by 5, and then you get x equals to 1 over 5, and then problem solved. All right, so my tip for you is that if you see the symbol as x, not located from the not located as you expected, then you have to think about what the context is in a certain problem and then solve it accordingly, right? For example, that's why we made up x on the example number 7, but we don't make up an x for a log function because we have a log equation already, and we have to use the equation to solve for x. Think about it. All right, that's all I want to show you this week. All right, make sure you study and practice more problems, and then I'll see you next time.